Good morning, everybody. Last class, we discussed about the melting furnaces used in melting of ferrous and non-ferrous metals. And already you have the melting furnaces used for different metals. They're like the type of fuel used, the type of metal melted, and the type of furnace used. The fuel may be coke, oil, gas, electricity. And furnace, cupola, crucible, open hearth, and electric arc furnace, resistance furnace, and last one, induction furnace. The type of furnace used and the capacity and the quantity of metal melted. That's very, very important. The furnace means the refractory lined metallic shell used to convert the solid metal into liquid metal. The type of fuel may be coke, oil, or gas fired or electric one. Next, we discussed the gas fired pit furnace. Usually, this type of furnace is used in burning of or melting of the non-ferrous metal and also sometimes cast iron. Next, resistance furnace. This is the commonly used furnace used in steel foundry and non-ferrous foundry. Next, come to the point, we discussed about the coreless induction furnace. Core means here there is no core at all. So for that reason, it is called as coreless induction furnace. The entire furnace looks like a bucket, and after melting, the entire induction furnace is turned 180 degree or even 210 degrees to pour the liquid metal into the tank. Next, come to the point. All of you, please write down the electric arc furnace. Most of the question paper, you have this question. Electric arc furnace. This is particularly used for melting of steel, and usually there will be electrodes are available. The electrodes are made from carbon. Sometimes the carbon with other metals are also added for different types of steel. And the electric arc furnace are classified into two. All of you observe here, there will be two types of arc furnaces are used. One is direct arc furnace, other one is indirect arc furnace. Now you just write down electric arc furnace. Electric arc furnace. Below that, write down only one sentence. The electric arc furnace used for melting of steel. Melting of steel. Full stop. In electric arc furnace, the electric current is used to generate electric current used to generate the arc. I repeat, in electric arc furnace, the electric current is used to generate the arc in the metal. Full stop. The arc developed between the electrodes, or between the metal and the arc, is maximum enough to melt the steel charge. Steel charge. Full stop. Next paragraph right down. In foundries, the power used write down one by one. Three-phase PHASE. Don't write FASC. Three-phase, 440 volts. Voltage 440 volts. Current 15 amps. Current 15 amps, and frequency 50 hertz. 50. Frequency 50 hertz. 50 hertz. Full stop. The electric arc furnaces are very flexible and clean. Stop. Next line write down. Electric arc furnaces are suitable for the production of high quality of steels. Next line write down. The electric arc furnaces are classified into two types. Write down one by one. Next line write down number one. Direct arc furnace. Usually in this furnace, the arc is established between two electrodes. Second one, next line write down. Number two, the indirect arc furnace. The arc is established between the electrode and the charge. Indirect arc furnace. The arc is established between indirectly, that is nothing but the electrode and the charge. Next, you write down Very, very important. Very, very important. Mark it very, very important. Write down the title. Direct arc furnace. Now, all of you write down the rough diagram of direct arc furnace. Starting with the construction of direct arc furnace. All of you observe here, bottom, they have made the circular or angular surface like this. Angular surface like this, on which you have the magnesite brick. All of you heard the refractory bricks. The refractory bricks has the temperature or the heat resistance. So this brick is made from magnesite. All of you observe here. This is very, very important. Magnesite brick has the capacity to withstand high temperature of about to 3000 degrees centigrade. For that reason, magnesite brick is used in the bottom of the direct arc furnace. All of you observe here, this looks like a container or a tank. Container or the tank. And between the metal and the brick lining, there will be a rammed horn. Usually, rammed horn. This is made by graphite or carbon particles. Graphite or carbon particles, or sometimes refractory lining is also used. The powder refractory lining, rammed horn. All of you observe here, looks like a U shape or V shape, curved V shape. This is made by using the powder refractory material. Powder refractory material. This is made in the curved shape. In that rammed hearth only, they keep the metal, maybe the scrap, steel, ore, and iron ore, and other metals like chromium, tungsten, molybdenum, vanadium, phosphorus, copper, and other metals are kept inside the container. All of you observe here, which looks like a U shape. They keep the metal raw material in the container, and this is covered by magnesite brick lining. Say above this, there will be a slag door. All of you listen properly. See, while converting the metal into liquid metal or molten metal, the waste particle present in the metal that converted into slag, which slag floats on the upper surface of the molten metal. Remember, due to density and gravity, the waste material present in the metal and slag which floats on the surface of the liquid metal. All of you observe here, the word slag, and this lining is the layer is called slag. This is the waste material that is removed from the top of the molten metal. It is present on the top of the molten metal. Before pouring the liquid metal into the ladle, the slag is removed from the slag door. Removed from the slag door. Anybody can tell me the use of slag? Because of a scarcity of sand, riverbed sand, scarcity of riverbed sand. Nowadays, for construction purpose, they are using slag sand. Slag sand. Remember, you are all belongs to mechanical engineering. The use of slag nowadays is used for construction purpose as a slag sand, which provides a very good bonding between the bricks and also surface lining. Surface lining. And all of you observe here, before pouring the molten metal into the ladle, the slag present on the surface of the molten metal, usually due to gravity, the slag floats on the surface of the liquid metal, that is removed before pouring. And the construction itself, there will be a magnesite brick lining is present of about 1 feet or 1.5 feet height. The magnesite brick lining is present. This brick lining is covered by steel shell that is called roof or curved steel shell. In that you have 3 electrodes. Remember here, 3 electrodes that is made from graphite. Made from graphite. Graphite is nothing but carbon. Graphite is nothing but carbon. 3 graphite electrodes are placed in the shell of the roof of the furnace, and all the 3 are connected to 3-phase power. 3-phase power, that is 440 volts, the current 15 amps, and the frequency 50 hertz. Write down all of you the title direct arc furnace and write down the rough diagram of direct arc furnace. In the bottom, intentionally they have made curved surface in order to turn the entire furnace 180 degrees or 210 degrees in order to pour the liquid metal into the ladle. Once all of you listen carefully, the principle of operation as explained earlier, this is the construction of direct arc furnace. Now the principle of operation. Switch on the 3-phase power supply. In all the 3 electrodes, the arc is established between the metal present in the container or in the furnace. Usually the metal, scrap, iron, ore, tungsten, chromium, molybdenum, nickel, phosphorus, copper, and other alloying elements are placed inside the container of the arc furnace, and the arc switch on the supply of power supply. The arc is established between the metal present in the container and the electrode. The arc has the temperature of 3000 to 4000 degrees centigrade, which is maximum enough to melt the metal present in the furnace. After 2 hours or 3 hours, the complete iron ore, the alloying elements are melted together, and which forms the liquid steel. Which forms the liquid steel. Then when the metal turns to yellowish orange color, all of you write down word, the yellowish orange color. Yellowish orange color, the color of the liquid metal is yellowish orange color. At that point, the operator of the furnace, he has the experience of temperature control. Just observing the liquid metal, he is saying the temperature of the metal is 2800 or 3000 degrees centigrade. And the liquid metal reaches 3000 degrees centigrade, which has the yellowish orange color. The operator understand that the metal is ready for pouring, and then he rang the bell in the furnace department that in the molding section they are ready for receive the liquid metal and ready for pouring the liquid metal into the mold cavity. This is the principle of operation of direct arc furnace. Direct arc furnace. All of you, please write down the direct arc furnace and also the rough diagram of direct arc furnace. Direct arc furnace. Write down the explanation. It consists of steel shell. Write down the explanation. It consists of a steel shell, comma, cylindrical in shape, with a spherical in bracket, write down semicircular or flat base, put a comma, which is mounted on rollers, to enable the tilting of the furnace, to tap out the molten metal. Tap out the molten metal. Tap out the molten metal. The shell is lined with 5 bricks. 5 bricks. 5 bricks. The roof is made of silica bricks. Full stop. The hearth, all of you observe here, this is the hearth, is lined with basic material, such as magnesite bricks, such as magnesite bricks and magnesite powder. Magnesite powder. The charging, that is nothing but the placing of iron ore, the alloying elements like chromium, tungsten, molybdenum, vanadium, nickel, chrome, and many other alloying elements are placed inside the bucket of the furnace or container of the furnace. Write down the charging, in bracket write down iron ore, comma, scrap, in bracket write down scrap, close the bracket, write down iron ore, comma, chromium, tungsten, molybdenum, vanadium, nickel, magnesium, phosphorus, etc. etc. may be done either from the top or from the side door or from the side door. Full stop. In top charging type of roof, can be swung on or turned along with electrodes. Comma, while inside charging type, comma, the side door is provided. And for removing slag, SLAG, removing slag from the molten metal. Full stop. A tapping hole with spout. Is provided to tap out the molten metal. Once again, the construction of a direct arc furnace, the top shell is made from steel, which has the provision to keep three electrodes, which is made from graphite or carbon, and these graphite electrodes are connected to power supply. Below that, there will be a container or bucket which has scrap, iron ore, the alloying elements like chromium, tungsten, molybdenum, vanadium, phosphorus, copper, like that. When you switch on the power supply, the arc is established between the metal charge and the electrode. The arc has a maximum heat and a temperature of more than 3000 degrees centigrade, which is maximum enough to melt the metal charge. After converting the metal charge into liquid, the slag floats, FLOATS, floats on the surface of the molten metal that is removed from the slag floor, and then the metal, liquid molten metal is ready for pouring. This is the principle of operation of electric arc furnace. All of you, please write down the question. Explain briefly with neat sketch. Explain briefly with neat sketch the direct arc furnace. The direct arc furnace. Put a question mark. Put a question mark. List the applications. List the applications and limitations. List the applications and limitations. Next, you write down indirect arc furnace. All of you write down indirect arc furnace. Write down the rough diagram of indirect arc furnace. Write down the rough diagram of indirect arc furnace. Listen and write down the explanation of indirect arc furnace. First, understand the construction. The entire furnace looks like a hexagon construction. Can you observe here? The entire indirect arc furnace looks like a hexagonal section. And all of you observe here the inside of the steel shell. See, the hexagonal steel shell, hexagonal shell is made of steel. The shell is made of steel. Again, the steel shell is covered with refractory lining. Refractory lining. And in the center of the shell, there will be a provision to insert the arc. All of you observe here. This is the carbon electrode which is connected to the power source, power lead, and which is placed inside the bearing. All of you observe here. This is the wall or tree union. Tree true union or wall, or usually the steel wall. The wall is made of steel metal and it is called true union. Above 6 feet or 8 feet, they place inside the bearing. All of you observe here. The ends of the copper electrode is connected to the power supply and which is placed inside the bearing. And this is the pouring spout and this is the door. And all of you observe here, bottom you have two rollers, which is used for tilting of the furnace into 180 degrees. 180 degrees. Usually, the indirect arc furnace is used for melting of the ferrous as well as non-ferrous. Remember, the direct arc furnace is used for melting of steel, but indirect arc furnace is used for melting of ferrous as well as non-ferrous metals. Ferrous and non-ferrous metals. Because of size, this is the small size indirect arc furnace available. Large size are also available. So, a versatile construction of the indirect arc furnace makes the foundry people use for small quantity, also large quantity. So this is the very versatile, easy, and it can produce clean metal. Clean metal is possible. Once again, construction of indirect arc furnace. Bottom, you have two rollers on which there will be a steel wall. This is called true union, on which the complete steel shell is placed inside the bearing. In the center of the bearing, there will be two carbon electrode and the steel shell as refractory lining, and the carbon electrode is placed inside the shell. When you switch on the power supply, the arc is established between the two electrode. All of you observe here, the arc. The arc has the very high temperature of 3000 to 3500 degrees centigrade. That is maximum enough to melt the steel charge that's present in the cell. And in the side door, all of you observe here, this is used for pouring of the liquid metal. This is pouring spout. This is pouring spout by the arc developed between the electrodes. As the arc is developed, there will be the powder particles of carbon which is melt in the end of the arc. Because of the arc is established between the electrodes. By observing the arc between the two electrodes, the operator will adjust the gap between the two electrodes. As you can say, the layer by layer, the arc is established, but layer by layer, the carbon particles are removed due to the establishing of the arc in the end of the electrode. Due to that, the gap between the electrode is less. For that reason, the operator will adjust the gap between the electrode in order to establish the continuous arc, so that the arc melts the steel charge present in the shell. So this is the principle of operation of indirect arc furnace. Indirect arc furnace. All of you, please write down the rough diagram. Now you write down the explanation. The figure shows an indirect arc electric furnace. The figure shows an indirect arc electric furnace used for large and small quantities. Write down, you add a word. used for melting of large and small quantities of ferrous and non-ferrous metals. Ferrous and non-ferrous metals. Full stop. The furnace consists of a cylindrical or hexagonal. All of you write down. This is very, very important. Hexagonal barrel. Hexagonal barrel. Shaped shell. Comma, lined with a refractory material. Lined with a refractory material. The shell is mounted. The shell is mounted on rollers. The shell is lined with a refractory material. Okay. The shell is mounted on rollers and can be tilted through 180 degrees. 180 degrees. This facilitates for easy pouring. Full stop. Also, put a comma. The rollers provide rocking action. Rocking, underline the word rocking, R-O-C-K-I-N-G. Rocking action to the furnace. Rocking action to the furnace. Rocking action to the furnace. That speeds up. That speeds up the melting rate. Speeds up the melting rate. Full stop. Speeds up the melting rate. Full stop. Two carbon electrodes. Two carbon electrodes are mounted on true union. All of you observe here. TRUNNION. True union. The two carbon electrodes are mounted on true union along the horizontal axis. Along the horizontal axis. And can be automatically adjusted for maintaining proper arc column. Full stop. A charging door and pouring spout. A charging door and pouring spout serve as charging and tapping, serve as charging and tapping purpose, full stop. This is a principle of operation of indirect arc furnace. Now you write down the question. Explain briefly with neat sketch. Explain briefly with neat sketch. Explain briefly with neat sketch the indirect arc furnace. The indirect arc furnace. Put a question mark. Indirect arc furnace. Put a question mark. List applications and limitations. List applications and limitations. Write any 5 application and limitations. End of the module, I will give you the common applications and the common limitations. You write the same thing for all the questions. Now, all of you listen. This is very, very important. Mark it. Very, very important. You have this question in the examination. 100% guarantee you can expect this question in the examination. Direct arc furnace or indirect arc furnace. Among 2 types of furnace, one is 100% guarantee in the second module. That's in third question. Now I stop at this stage. I will call the attendance. All of you answer roll call, unmute yourself and tell me the attendance. Answer roll call. All of you unmute yourself. Karthik MK.
Present, sir.
Akshay M. Patil. Mohan Raj MB.
Yes, sir.
Bhagat HR.
Yes, sir.
Dhanush. Nutan.
Yes, sir.
Krutik.
Yes, sir.
Mohan Raj. Sushant.
Yes, sir.
Vivekanand. Pawan HR.
Present, sir.
Chandan RC. Kumaraswamy.
Yes, sir.
Manoj YB.
Yes, sir.
Pratik S.
Yes, sir.
Chhatrapati Chetu.
Sir.
Mohammad Raja.
Yes, sir.
Nayaz Sharif.
Yes, sir.
Sharat Madik. Harsha Yamar. Danish Bhatt.
Present, sir.
Hemant Nuchin.
Present, sir.
Abhilash.
Present, sir.
Mithun Naik.
Present, sir.
Ganesh Naik. Adil SU.
Present.
Karthik R.
Present, sir.
Nanesh.
Yes, sir.
Manoj H.
Present, sir.
Vignesh HV.
Present, sir.
Prathamesh.
Present, sir.
Kishan Ahmad.
Yes, sir.
Lohit Kumar. Kumaraswamy.
Yes, sir.
Abhilash. Aditya.
Yes, sir.
Nutan.
Present, sir.
Nishchit Gowda.
Present, sir.
Okay, anybody else? Please tell me.
Sir,
your name.
Harshavardhan.
Sir, Hemant KS.
Okay, Nazma, okay. Next,
Sir, Harshavardhan.
anybody else?
Aditya.
Hemant KS.
Okay, Hemant KS. Okay.
Aditya.
Okay,
Aditya.
Aditya. Okay. Next.
Malhar. Malhar. Dude.
Hello.